Welcome to the Math Podcast. Today we're going to be talking about titration and titration versus other hyperoperations. So what's your favorite? Mine is titration because my math is strong, so I can do that. It is the first one after exponentiation where things start to get a little weird and look a little different than they might when you're doing normal operations and equations and seeing normal signs and exponents, things like that. Things start to go a little backwards and a little hyper, a little upside down, at least in some ways that you might want to solve them. I see things like operation and titration and even pentation as ways to expand on things like operation and even titration itself, like doing a conversion titration or titration iterate. So combinations of the two are actually like that for me, my favorite, like a titration and a pentation at the same time, or a titration iterate and a titration when you have an iterate that goes around the quadrants and plots the function of a hyperinfinite function. Where they are independent methods, this is divergent is the biggest hyperoperation, and is convergent like a wave using two at once more efficiently, like converging and diverging at the same time, or at once more efficiently. As efficient as alternating them are the superfunctions and iterates and iterative superfunctions, or hyperinfinite sum, or dual hyperinfinite sum, etc. That comes about, and the numbers that come after that, like new hyperreals or anything else. Titration iterates. When titration iterates use things like dual hyperinfinite sums and fixed points in the unsigned area, or triple hyperinfinite sum strings for bigger sequences, or maybe a big enough hyperinfinite sum. Is every convergent iterate that would be bigger than two divergent, more appropriate in functional hyperinfinite metaphors. Two divergent iterates have more interdependent hyperoperator equation than tricomposite functions. Every convergent iterate that would be bigger than two divergent iterates would have more interdependent hyperoperator equation than tricomposite functions equation whenever everything more derivative more than that derivative and as derivative as that was an equation is something that at least couldn't hyperoperate on a bicomposite function and certainly wouldn't operate on a tricomposite function. So do things like function variables that expand as the variables of dual hyperinfinite sums or hyperinfinite sums, and things that are big enough, even things with two numbers like that, and the derivatives and the fixed points hyperinfinite mistake possibility make the function variables that aren't triple hyperinfinite sum big enough, like a hyperinfinitely large enough triangulation equation group or triangulated superfunction group or superfunction group into as big a variable generator as possible or not. Function variables can. They can, especially if you think of having a variable in mind and transposing. And thinking of equations where you can transpose variables more easily. They also do when a function is as big as the superfunction or superfunction group and can split into variables. Then the variables can be transposed more, and an answer can be given or back derived. Do things like multiple function variables at the same time make things bigger, like hyperinfinitely large enough pattern groups or rings. How about supersets and superset systems that use two slopes and two derivatives? It does when the things like hyperinfinitely large enough pattern groups or rings change or don't change enough at the time or often enough. Do that kind of a thing. Supersets and superset systems that use two slopes and two derivatives. This is true for them. These ones change as well, but not quite as much, so it's less likely to be the case, unless you operate a lot more or divide more, something like that. The variables, the function variables, could not divide more, or could, or make things like decompositions and bicomposite functions, or hyperoperators. won't even work or be enough. So, a dual hyperinfinite sum or large enough hyperinfinite sums or triangulated equation would be to extend to complex numbers. You could think like for a hyperinfinitely large enough pattern with two hyperinfinite sums and dual hyperinfinite sums, or even just one large enough one. They can hyperoperate on a bicomposite function in that way. Anytime anything more derivative than an x is like a bicomposite function, make it so that two hyperinfinitely large enough bicomposite functions can stop or prevent hyperoperations from something that would be like a bicomposite superfunction or triple hyperinfinite sum function and superfunction group. Then you could just reiterate and use the grid and really exponentiate without using all the syntax. And the tricomposite function that the sum, or the triangulation had an hyperoperate on wouldn't be like two tetrations or a triple hyperinfinite sum function. This is the way it sort of goes with tetration, as well as using tetration or pentation at the same time as each other or something else, as well as transposing with variables in mind. When you do that, it not only becomes easier to not have to do something, but it becomes easier to not have to do something and to have to do something at the same time, and eliminating the not having to do something, like mistake possibility, making it very easier to do bigger equations and handle bigger numbers. The previous equation we were talking about, with everything more derivative than something like an x, or everything more derivative than it, being its own number or number of things, like a hyperinfinite sum or two hyperinfinite sum, and having variables in mind to transpose with, and not letting anything else to hyperoperate in a bicomposite function, unless you found two dual hyperinfinite sums that were big enough, or a big enough one, which you could do with a quad composite function, and break the bicomposite and tricomposite dehyperoperation sequence. It's like anything more derivative than an x or two x's. It's like a bicomposite in triple hyperinfinite sum function. It makes it so that two hyperinfinitely large enough bicomposite functions are x, and x cannot hyperoperate on bicomposite function, cannot hyperoperate on tricomposite function, but can operate on things that are not in a sequence with an x or an x3, an x3rd and x's. These two types of tetrations diverge and converge alternatingly, hyperinfinitely, and can be used in two tetration extensions at the same time. They are like the two hyperinfinite sums, which can hyperoperate on the bicomposite function, and can be used in two tetration extensions at the same time, or times, hyperinfinitely, and make a tetration that converges and diverges at the same time, as well as two others that can sum a variable with dual hyperinfinite sums, or triangulation, and triangulate two variables better with triangulation equations, like you would refer to a normal equation like a Schrader equation. Schrader equation. About having to do basically two things at the same time. Like, for instance, triangulating method to solve a variable, or basically triangulating something and out deriving something like a system set big enough to solve a variable. Two operations at the same time. It's like doing two triangulating equations at the same time and using the two antiderivatives instead of big enough hyperinfinite sums, dual hyperinfinite sums, to operate on the bicomposite function, to be able to hyperoperate on the bicomposite function and partition enough of everything and everything more derivative than x, like its own triangulation, and you solve a variable as well. With pentation, the two variables have to have enough of the same sign to not look as tetraconvergent as big enough tetrations to make iterates, etc. So that's one way that it's kind of like not doing pentation to tetrate something like that. So how fast the numbers are going and everything else like that. It's just too interesting because of things like some of the hyperinfinite sums or dual hyperinfinite sums, or even two triple hyperinfinite sums, or two triple hyperinfinite sums and a hyperinfinitely large enough one, like 4. That's how they differ, and how the hyperoperations can kind of look like tetration in it. If you do both hyperoperations at the same time, and don't have to do it at the same time, it would make the point. The point that you can hyperoperate when anything more derivative than like a pentation hyperinfinite sum is like a big enough hyperinfinite sum, or two dual hyperinfinite sums, or dual hyperinfinite sums, rather, and anything less derivative would be like two variables or a function, like transposing a variable or solving for a variable, even by transposing. Two pentations in hyperinfinite tricomposites can triangulate that, or triangulate that a lot more. With two pentations in a something at the same time, we can get to quad composite functions. 2. Use the quad composite function with tetration and two tetrations at the same time to keep the numbers going and see what they really look like and how those fours work together. Hyperoperation like two at the same time, quad composite functions, and tetration. So how does tetrating or hyperoperating so fast you can be doing two hyperoperations at the same time that aren't? Show that big enough hyperinfinite sums differ from two others. One hyperoperator with a bicomposite or two tricomposites, or one quadruple composite function, or two of these at the same time, in and out of anything, in and outside of anything. Anything more derivative than x actually gets triangulated and can make big enough hyperinfinite sums and superfunction bicomposites that can be hyperoperated on. So two tetrations at the same time can tetrate away to not have to do so much, and it's great for dual hyperinfinite sums. And hyperoperators, like outdriving dual hyperinfinite sums at the same time. One's big enough to hyperoperate on derivative of a function, like bicomposite functions, and antifunction, like tricomposite functions, which are bigger than the bicomposite function, and composite functions can order high enough to stop more derivative things. This makes titration like a big enough tricomposite function or superfunction system, because of how much numeracy there is, or how many numbers there are. Doing two of these at the same time, not only at the same time, but at the same time as triangulating or diverging, or two alternations of diverging and converging at the same time, can make some iterates that put variables outside the superfunction. See it for the 15-minute podcast episode talking about tetrating and tetrating things at the same time. More in the next episode, more on tetrating, pentating, hexating and pentating at the same time. Not having to hexating, pentating, tetrating at the same time, so like 4. How those numbers add up, how they make more hyperreals. More hyperreals at the same time as other numbers, etc. They more thinking hyperinfinitely. That's it for this time.